Hi, this is Richard C. I'm a math tutor here at Wyzant, and I'm solving a geometry problem that was submitted by a student having to do with a chord with a central angle. And apparently there's a formula you can memorize for this, but I really just want to reason my way through this and show you how to approach it with a diagram. And you'll see the solution's pretty simple. You just have to remember a little bit about chords. So not particularly difficult, I think. So we have a central angle, which is 80 degrees. So I'm going to start with that. Oops. Let me just find the center here. Say that's the center of the circle. Now we'll put in a central angle here with that's 80 degrees. And then we're going to put a chord in here. It may not be entirely clear from the words that this is actually the diagram to do, but there's really no other way I could think of drawing it. So I'm pretty convinced that this is the right way, sort of by process of elimination. Okay, so what we're interested in is the length of the chord, this chord here. And so all you have to do is remember there's a theorem from geometry that says if you drop perpendicular here, it will bisect the chord. So let me fill in the right angle here. So it should be fairly clear to you that the radius is 4, so that's a 4 and a 4. It should be clear to you that these two triangles are congruent. They're both right triangles. They have the same hypotenuse and they have the same altitude here. They share the same altitude. So they are congruent triangles from HL. Or you could just remember the theorem about the perpendicular bisector on a chord. And the central angle is 80, and so because these two triangles are congruent, although they don't look it on my diagram, they look almost congruent, I guess. So that's going to be 40 and 40 for these two angles here. Okay. So now solving this just basically reduces to a SOHCAHTOA problem. I'll use this triangle, this upper one, and we can see, hopefully, let me just remind you of SOHCAHTOA. So the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Whenever you're working with a right triangle, the first thing that should come to mind is SOHCAHTOA. SOHCAHTOA is useful, but it is limited to the right triangle. You can see here that we're interested in this half. This would actually turn out to be half the chord because these two triangles are congruent. So that's x, and this would be another x here. And so these triangles are congruent. So we can just use the sine here. So the sine of 40 degrees is equal to x over 4. Multiply both sides by 4. And then put that into your calculator. And what I get is 2.57. And of course, we want twice that. We need 2x. And when you multiply that by 2, you get 5.14. and that would be centimeters because we're measuring the radius in centimeters. And so that's it. That's the whole problem. Quick and easy. So there are several ways to approach this one, but I think the visual approach is always best in geometry, and it saves you the trouble of having to remember any special formulas for the situation. It's pretty easy and straightforward to solve. You just have to remember about the perpendicular bisector of a chord. And that's it for today. I hope you enjoy what's left of geometry this year, and I'll see you next time. Bye-bye.